Welcome back to Physical Science 20. So we will look at the last type here of double replacement reactions, and that is neutralization reactions. So in earlier courses, you may have learned that if you have an acid reacting with the base, it causes a neutralization reaction. So the end result is a mixture with a pH closer to 7. Now you may recall, or maybe you don't, so the pH is a scale that ranges from 0 to 14. I'm going to run out of room here very quick. 13, 14. I squeezed it in. So a low pH means your substance is acidic. A high pH means your substance is basic. And then around 7, we have neutral substances. So if we have an acid and a base, they neutralize each other, making a pH of 7. So if you look at nitric acid, it can be neutralized by the addition of sodium hydroxide. The chemical equation is this. So nitric acid, of course, is the acid. And anything with a hydroxide, for now, we can assume is a base. And if we take a look at the double replacement reaction, so we have H plus and hydroxide, which could come together. Because if we take a look at what we have here, we have H plus and NO3 minus, and then sodium and hydroxide. So we have H and OH come together to make water. Now, quite often we could just represent water as that, showing the H and the OH combined together. And then sodium nitrate. Again, positive ion first, negative ion second. So then we have our sodium nitrate over there. And all of these are aqueous, so dissolved in water, dissolved in water. Water itself is not dissolved in itself, so you simply call it L for liquid. And sodium nitrate is a salt or ionic compound. You can see that the solution is neutral here. It has water plus a solid dissolved in it. So it's really the same thing here, except we're dealing with H and OH coming together to neutralize things due to making water and then having that salt or ionic compound. So if you think the water, so over here I just mentioned, you think of water consisting of H and OH, then neutralization follows that pattern. If you keep water as H2O, it's a little difficult to try to rearrange everything. So if you keep it as HOH, we have our hydrogen, which acts like a metal, and our OH group, which acts as a nonmetal. Look at another example. Antacids are medications that neutralize excess stomach acids. So for example, Tums, Pepto-Bismol, etc. Magnesium hydroxide is often used for that. And it could neutralize excess hydrochloric acid in your stomach. Because yes, you produce hydrochloric acid in your stomach. So H plus negative for the Cl. And then magnesium is 2 plus. Hydroxide is minus 1. That's why we need 2 of them here, because to combine with that magnesium. So again, take a look at what happens here. We have H from the acid and OH from the base making HOH or H2O. And then magnesium with chloride, 2 positives, 1 negative. So I'm going to have 2 of these Cl's. So there they go. If I have 2 Cl's, put a 2 in front of here to give me my 2 Cl's. Gives me 2 H's, which I have here. But then again, I have OH's over here. So if you go through the balancing, you'll see that the coefficients are 1, 2, and 2, 1. So note that these reactions generally do not produce precipitates. What we can do, though, is test the pH to see if that pH is around 7. Because if it's around 7, then we know that it's going to be neutralized and be a neutralization reaction. All right, so that's in for double replacement. We'll see you again.